telescope fired off into the unknown, not so unknown now, we have been curious to know what new things it has been able to discover in space. Well, the first thing you all need to understand is that before Webb begins to discover and report new things, it's going to spend quite some time studying in detail things that have already been discovered by other instruments, like the Hubble Space Telescope. Webb as a successor to Hubble. The Hubble Space Telescope has helped NASA locate many black holes, observe the size and growth of the Milky Way, measure the age of different stars with a 10% accuracy, and take into account supernova reappearances. This has provided scientists with sufficient information, discover the age of the universe, and solve astronomical mysteries, all while discovering new ones. But when the Hubble Space Telescope was first launched, there was a manufacturing error it suffered. The very first images that Hubble captured were quite blurred. The problem was so profound that both the image's clarity and color were. When one of the telescope's primary mirrors was being polished, its edges were flattened just a little more than needed, so it could no longer focus. The flaw was minute, at just 1/50th the thickness of a sheet of paper, but that was big enough to cause major imaging problems. This problem is called spherical aberration. In the first space repair mission, a team of NASA experts went into space via a space shuttle in 1993 to fix this issue. It was followed by many similar missions. On the 13th of June 2001, the Hubble Space Telescope unexpectedly shut down. Observations showed that this was due to a problem in Hubble's power control unit. According to the experts at NASA, the solution involved the precarious task of turning on computers on the telescope. Paul Hertz, NASA's director of astrophysics, said, "If you do it wrong, you can leave the spacecraft in a situation where you might not be able to recover it, so you want to make sure you don't do it wrong." He went on to add that, "I think that's the level of care and risk we want to be aware of as we move forward." 5 weeks later, the backup hardware was turned on successfully and the telescope was up and running again. Even though the problem was solved and Hubble's full glory was restored, one thing had been evident to space enthusiasts since the very beginning. If they wanted to continue to explore any more of space, the Hubble Space Telescope would need a successor. And now, this had to be sooner than later. The James Webb Space Telescope has been underway since the 1990s, but was finally launched on 25 December 2021. The features of Webb that give it an advantage over the Hubble include its unique orbit around the Sun, while Hubble orbits the Earth. The point of orbit of Webb is the second Lagrange point, or L2. It is 1.5 million kilometers away from Earth. Webb will be able to cover a larger distance than Hubble did, and will also be able to map a larger area of space than Hubble did. Another major difference between the two telescopes is that the Hubble uses visible light and ultraviolet wavelengths to observe objects in space, while the Webb uses infrared wavelengths. Because of this, Webb can view objects in the cosmos almost 100 times duller than the maximum Hubble can observe. Physics says a shorter wavelength means a resolution and sensitivity for not just telescopes but for all images and objects, including microscopes. So by using Webb, we will be able to see clearer images of space and might be able to find something new that we have not been able to discover with Hubble's old technology. There are other more scientific differences as well that are best left for astrophysicists to explain. But, for the record, one feature of Webb that NASA's official website states is that Webb will have an approximate 6.5 meter diameter primary mirror, which would give it a significantly larger collecting area than the mirrors available on the current generation of space telescopes. Hubble's mirror is a much smaller 2.4 meters in diameter, and its corresponding collecting area is 4.5 meters squared, giving Webb around 6.25 times more collecting area. The James Webb Space Telescope also has the fantastic feature of being able to peel back layers of dust covering celestial structures to give us a clear image of what lies beyond. It has used this feature to observe structures like the Tarantula Nebula, the largest and brightest star-forming region in the local group, 161,000 light-years away from Earth, and Stephan's Quintet, a visual grouping of 5 galaxies, of which 4 form the first compact galaxy group ever discovered in the constellation of Pegasus. Though Hubble also observes these bodies and regions, Webb offers a clearer view for the reasons we have discussed before. Another region that Webb has been able to observe is of critical importance to man's search for its origin and that of the universe. Though this region is surprisingly small and far away, it is significant because it marks the edges of our universe and contains the oldest observable celestial structures. The approximate size of this region can be understood by the fact that a grain of sand held at arm's length would be enough to block it from the view during the night. However, despite its small, almost negligible size, the region remains observable because it possesses thousands of galaxies shining brightly. The pictures of the region make it Webb's first deep field. Though the images may seem one at first sight, it is actually a combination of 1,000 images taken from different angles. The galaxies visible in these images are so old and so far away that their light has only just reached us. To be exact, the galaxies are 13.1 billion light-years away. The galaxy cluster most visible in these images is the SMACS 0723. When looking at this cluster, we are looking approximately 4.6 billion years into the past. The SMACS 0723 forms part of the southern constellation of Volans and has remained the focus of Hubble for a long time too. The difference between images of the region taken by Hubble and those taken by Webb are very easy to observe. It took Hubble 10 days to develop this image with a much lower quality, while it took Webb only half a day to give us a much clearer picture. This means that, given more time, Webb will be able to provide us with an image of the SMACS 0723 that may be able to answer our questions regarding the origins of the universe. Conclusion: every new development in space technology, or even science in general, seems to be taking us closer to discovering our origin and to a solution to our problem of Earth being the only livable planet. However, when studied in depth, we seem to be no closer to these answers than when we were 1,000 years ago. We are observing the same skies that our ancestors studied. We are moving around in circles, reaching and using the same theories generation after generation. Will we ever be able to discover the true nature of the universe and its birth